In this video, we're going to solve linear equations in one variable, including those where you got the distributive property, including where variables are on both sides. I've thrown one inequality into this, but it's really the same principles. But basically, we're just solving equations. So, what is the value of x in the equation? X over 7 minus 5 equals negative 4. Well, first strategy is I'm just going to use my inverse operations. If I add 5 to each side of the equation, we then have x over 7 equals 1. And then if I see x is being divided by 7, my inverse operation would be to multiply each side of the equation by 7. And that cancels and leaves you with x equals 7. I like that. Now, here's another strategy. If you got a solving equations problem and it's multiple choice, you should be jumping for joy on your STAAR test, because I don't even really have to know how to do a lot of algebra. I can just guess and check. Like, for example, if I were to take x over 7 minus 5 equal negative 4, and let's say I didn't know how to do all this, let's take my first answer choice. Let's take answer choice A. And I'm just going to substitute in for x. Negative 23 divided by 7 minus 5 equals negative 4. If I were to put this into my calculator, let's see. Negative 23 divided by 7 minus 5. In my calculator, this ends up being negative 8.2 something, and I can see that that's clearly not equal to negative 4. So I just threw this whole left side of the equation into my calculator, and I get something that's not negative 4. Therefore, x is not negative 23, and we could just eliminate it. And so then I can just go through my other answer choices. Excuse me, I'm going to try to erase that. Let's say we found out that A didn't work. Let's say we find out B didn't work. Let's go down to C. Then I'm going to substitute in 7 for x. Well, 7 over 7 is just a 1. And then I can do 1 minus 5 and see that negative 4 actually is equal to negative 4. Because I result in a true statement, that means that 7 is the solution to this equation. Therefore, 7 is the answer. So know that you can answer these questions not only by using the inverse operations, but just by guessing and checking with your answer choices until you result in a true statement. What is the value of x in this equation? So, got a little distributive property here, nothing to be worried about. I'm going to distribute right here. Then I have 8x minus 4 equals 2x plus 35. And now I've got one of these equations with variables on both sides. So the way that I explained it is I like to choose a side to get all my variables to, and I like to choose a side of the equation to get all my constants or all my numbers to, and then act appropriately. So for example, if I want all my x's on the left side of the equation, just because I chose that, that means that this 2x is out of place because it's on the right side of the equation. So I want to bring it over to the left side of the equation. And the way I do that is with inverse operations. If I subtract 2x from the right side of the equation, I have to also subtract x from the left side, excuse me. Then I have 6x minus 4 equals 35. Now notice, I said I want only constants on the right side. I want only numbers here. That means if I have a number right here, I have a constant on the left side of my equation where I'm only supposed to have variables. That means I need to get negative 4 to the right side of the equation. So I do that by adding 4 to each side. And then I have 6x equals 39. One last easy step is divide by 6 on each side. And then we're left with our answer. 39 divided by 6 should be 6.5, but I'm going to check by putting it on my calculator. And we do. We get 6.5. So, bam. Now, how do you check your answer? The way to check your answer could be considered its own strategy, but as we did on the last problem, couldn't I just take each of these answer choices, put them in for x, and see which answer choice resulted in the left side of the equation being the same as the right side? So, for example, if I had 4 times 2, and I wanted to see if my answer was actually 6.5, I can substitute it in and see if that's equal to 2 times 6.5 plus 35. And I'm running out of space on the right side of the screen there. But if I were to simplify, that would be 4 times 2 times 6.5 would be 13. And on the right side of the equation, I've got 2 times 6.5, which would be 13. And then, okay, so the 2 times 6.5 is the 13. and then we're going to bring down our add 35. So I just work those out to get that, work those out to get that. I'm just taking this step by step. 13 plus 35 is 48. 4 times 12 is obviously 48, which equals 48. So, you know, I solved the equation using inverse operations, got x equals 6.5, but then I can check it just by substituting it back into both sides of the equation and making sure that it results in a true statement. Okay, which value of x makes this equation true? So we got some distributive property, we got variables on both sides. I'm just going to tell you the reason I included this problem is because of that negative right there. I think we sometimes struggle to distribute negatives. So I'm going to recopy everything right here. A lot of negatives. We're going to have to really pay attention to detail on this problem. So when I distribute, first thing I got to do is I want to simplify by distributing. So on the right side, that's a pretty easy distribution. I'm going to distribute that negative 2 into both sides. So negative 2 times 3x would give us a negative 6x. And negative 2 times negative 4 would give us a positive 8. Now over here is where we have some trouble. If I have a negative in front of parentheses, that means this negative applies to both values in the parentheses. So sometimes I'll draw like a little 1 there to show that it's kind of like distributing a negative 1 into both. Like I'm going to multiply both of those terms by a negative 1. A negative 1 times a negative 7 would give you a positive 7. And then negative 1 times negative 4x would give you a positive 4x, and then I can bring down negative 5x. Now, I can do the same thing where I can decide, that I want variables on this side and constants on this side, but first I have some simplification I can do. I've got negative 5x and 4x, but they're on the same side of the equation, so I don't want to do this stuff where like add 5x here and add 5x here, because you'd be adding it twice to the same side. Like some of you, for example, would want to subtract 4x there and subtract 4x there, but you wouldn't do that because notice how, aren't these both on the left side of the equal sign? You only want to use inverse operations on opposite sides of the equal sign. Since these are on the same side, I can just combine them. Negative 5x plus 4x is going to give us negative 1x plus 7. I just still bring down the plus 7, and that's equal to negative 6x plus 8. Now we're ready to do the stuff where I choose a side to get all my variables on, and I choose a side to get my constants on. If I want only variables on the left side of my equation, that means, look, I've got a negative 6x right here. I want that over here with all of my x's. So I can get that over there by adding 6x to each side of the equation. Anything I do to one side, I got to do to the other. And then that leaves us with, let's see, negative 1x plus 6x is 5x. I still have my plus 7, and that's going to be equal to 8. And then I already said I want only constants over here. I have a constant on the left side of my equation, so I'm going to use my inverse operations to get it to the other side of the equation. 5x equals 1. And then my last step is division. I'm going to divide by 5 on each side and get that x is 1/5. Okay? Now, 1/5 is the same thing as 0.2. So if you were to check this answer by substituting that number in, you got to be careful putting this whole thing in your calculator, but I'd probably do the decimal form of it, 0.2, substitute a 0.2 there, a 0.2 there, and a 0.2 there, and make sure this left side equals the right side. But yeah, really the main idea is knowing how to distribute that negative, and the other main idea is being able to combine those like terms right there. Okay, last problem. This one's an inequality, okay? So, here we go. 5, 3 minus x is less than negative 2x plus 6. I'm going to start by distributing. I have 15 minus 5x is less than negative 2x plus 6. And then this works the same way as the equations. I'm going to choose to get all my variables onto one side. I'm going to choose to get all my constants onto the other. Well, if I want all variables on the left side of my equation, I've got this negative 2x. That's a term that has a variable. I want it on the right side of my equation. I can do that by adding 2x to each side. And then I have 15 minus 3x because negative 5x plus 2x is negative 3x. And that's going to be less than 6. I've already said that I want all numbers on the right side of my equation. So I have a constant right here of 15, and he needs to be on the right side of the equation. So I'll subtract 15 from each side and get him over there. And now I'm here. Negative 3x is less than negative 9. I have one step left to get the x by itself. Actually, I'm going to divide by negative 3 on each side, and I have x and 3. What you have to remember with problems like this is that whenever I divide by a negative on each side of the inequality, that symbol's got to flip. So our answer is that x is greater than 3, okay? So that's really the main idea, reason why I included this one. If we're solving one of these inequalities that operates the same way as an equation, this inequality separates both sides just like an equal sign separates both sides. But whenever I multiply or divide by a negative on each side, I've got to flip my symbol. And that's why we have x is greater than 3.